All right, so let's start looking at some of Promises. The good thing about as I told you that we spend a lot of time in JavaScript. In fact, year three students, they have one session which is 2 hours lecture, one session that's 2 hours is a lab, and that's 1 week. You guys are doing one session this night would equal one 1 week for them, right? And they would do a module like this in 3 months. So this is certainly compressed. Um, so we've probably done the equivalent of 2 semesters, really. So now we feel like we can, at this point in time, we can start to look at some intermediate JavaScript. And I would say when we get into asynchronous stuff, it gets hard, but it's fun as well. You can start to see some really cool stuff, especially when we get into now. We can get into some of the other technologies because we have a pretty good foundation. We've been doing JavaScript now for like it's probably been 6 weeks already, right? 6 weeks, at least 20 sessions. So we should be able to take on some asynchronous stuff. And going into that, we're going to talk about promises. All right, so we're going to look at, we already talked about synchronous JavaScript, and there's the concept of asynchronous JavaScript. And when we're talking about asynchronous JavaScript, we can also get into some of that ES6 promises, promise object. And on that promise object, there's some methods, built-in methods. And we can start to look at callbacks, what a callback is versus promises. Now, we're going to use callbacks quite a bit in Node.js. So if you don't get them at first, that's all right. Again, some of this stuff is a primer for what we're going to be getting into in Node.js. And Node.js is all about asynchronous JavaScript. So if you don't know synchronous versus asynchronous, what that means, as we stated earlier, JavaScript is synchronous, right? So what that means is that JavaScript is synchronous blocking in single-threaded language. So blocking means that you can block your whole execution, right, on a single thread. Synchronous may be something like make a call to the server, wait for the okay. I'll give you even a better example. I did a shopping cart. I should actually do it. I don't think it's a ticket website like Ticketmaster sells sports tickets. I'm sure now they're not selling anything, but I remember to this day, there's a bunch of things I needed to do, but I did it synchronously. I didn't understand asynchronous coding at that time. So the first thing would have been at checkout, create an account. So I would take the information from the user, create an account. That's a synchronous operation. You have to wait for it to return. When it returned, then I would open a connection to the third-party payment processor. So whatever it is, Moneris or something like that, to process PayPal, to process the credit card information, make a transaction, wait for the request, right? So I'm doing one after the other. The next one would be persist the order in the database, right? Open a connection, store the data, and then wait for the response. And then at the end of the day, send an email. So 4 steps, all synchronous. One had to finish before the other one started. And what I did is I threw up an animation. Like basically I just said, okay, this is way back when. I said, I estimate that this whole synchronous flow will take about, 90 seconds. So I'm going to estimate it's 90 seconds, and I'm going to show that loader for 90 seconds. And I'm just going to throw it up there, and it's really bad actually. It's going to cover about 90% of the situations, 95. But then there's that 5% that went over my estimate, and then they failed. And nobody would, like that company that when I worked for, they're like, why is these messages failed? And I didn't know how to handle those because I didn't know how to handle asynchronous programming. But all of those were done in a synchronous way, and there's a lot of better ways that we know now to handle that kind of thing. This is a long time ago, right? So what that means in that example on this one is that only one operation can be processed at a time, right? So the database, the creating account had to be processed before the transaction to PayPal to process the credit card. And if PayPal doesn't respond in a very reasonable fashion, then that's a block. The whole code blocks because now it's permanently waiting for a response. And if you've ever been on a e-commerce website, you just get that spinner, right? Something's happening, maybe something didn't return. Now you're blocked. And then what do you do, right? The interface is now frozen. Your transaction happens all the time. Maybe they're doing synchronous processing in a synchronous way. So that's what can happen. So if you look at a synchronous stack that's blocking here, you have function A, function B, and then you have a bunch of stuff that's happening. And you know, any one of these things you can see 1, 2, and you can see some nested stuff going on. So function D, number 7, may never actually execute. In fact, somewhere deep in any one of these levels, something can happen that stops the whole stack. And then you get an order that's not processed. You don't know why, right? So, but we can make things behave in a very asynchronous way. But it's not part of JavaScript. We have to use those APIs to make that happen. So we have to rely on some of these other things to make that event-driven, asynchronous feeling that is JavaScript, right? So if you didn't know that, then that's something to remember, is that we have to leverage a lot of the built-in APIs to make this work. There's a concept of callbacks, and there's a concept of promises. We also looked at set timeout and some of those built-in things we can all leverage. But so here's what asynchronous would look like, right? So in my example, asynchronous would be creating the account, processing the credit card information. They can happen at the same time. They don't have to wait for one another. They can both fire at the same time. Maybe they return at different times. Maybe you have a third operation, which is like send an email out. All 3 of those can happen at the same time. You can wait for all of them to finish, and then only then persist the order to the database. And then when all of that's done, you could actually have a situation where, okay, everything is done. Then I hide that loader and I redirect to say, hey, your order is completed. Everything is done. You're all good, right? And it happens a lot faster now because now, and if you notice in my example, you have a lot of control, right? Whereas before I was just guessing. I was just putting a timer saying, hey, show that loader for 90 seconds, which is not great, to be honest. Anyhow, so the earliest and most straightforward solution to being stuck in the synchronous world is to use the asynchronous callback, which is set timeout. Set timeout works by giving it a timeout. As we saw in our previous example, you give it a duration, say 1 second, 10 seconds, 1 hour. It's going to fire 1 hour from now, and then you provided a function. So that function is called a callback function because it gets called an hour from now, right? It's basically like a reference point. When that hour duration is up, when this timer is completed, it's going to look at the function, it's going to call it. So in a way, you can defer stuff. You know, if you hit it, you can say, okay, I don't need to do this right now. I can fire that email a day from now. So get it out of the execution path. I'm going to fire it. It's going to be queued up. It's going to fire a day from now. I don't have to do it all at once, right? So you can use things like set timeout, set interval, and there's another one in there, set immediate, I think it is. But so it's a really great solution because you can't predict exactly when. So for in this example here, if you look, there's function A, B, C, and then D, right? So we don't know when C is going to finish. We don't know, with all that nested stuff going on in there, you can see over there. That's a problem, right? We don't know what's going on in there. That could be something like persisting databases, or who knows what's going on in there. Maybe it's going to do some calculation that's crazy. Maybe it's going to go and download a huge file to, like if it was Netflix, it's going to download something to stream. We don't know what's going on in there. We don't want to block everything. So we could set it on a timeout. And what that does is it defers it. We have a queue over here. So this is something we're just visualizing that this is basically is going to run an hour from now. When it runs an hour from now, then we're going to process it in this main thread. So it's a way of deferring, right? So this situation gets messy really fast, and so this situation of deferring things can get messy very fast because there's all these callbacks. So the callback is when one thing happens, call back a function, then call back, then call back. You get a very common problem. I'll show you what it looks like later on. It's called callback hell, and it looks really awful, right? Because you have you got stuff that's very unreadable, and you have a lot of spaghetti code. You'll look at it and be like, whoa, I can't even understand what's going on there. I don't know. So we have a concept called promises, and promises cleans up that whole Christmas tree effect. We'll see what that looks like. Just imagine a Christmas tree, right? How it goes, the branches kind of, if you turn it inverted, you'd have like a little bit of a triangle going. That's what it would look like. I'll show you it. It looks ugly. So they have this method called promises now. One thing to note about this this picture here is there's a queue happening here, and there's something called the event loop. And just remember that term event loop because Node.js is all about the event loop. And the internals of that, the architecture is based on that. So it's a pretty interesting concept. All right, so asynchronous programming. So async programming is common in JavaScript because we have a lot of animations. Like I said, loading, very simple animations, that loader, right? The page loader, that spin wheel, we need that, right? But there's a lot of transitions that happen in JavaScript, especially on mobile devices, the swiping, pop-ups, all that nice kind of responsiveness, right? That's all animations. There's a lot of server requests going on, right? To persist data and get tokens and get, all that stuff, right? So the classic solution is the callback. Now, remember that the classic solution is the callback. So we're going to use callbacks a lot in Node.js. One thing to know about Node.js, and when I told you about ES6 and the specification, is we're learning these syntaxes, but not every browser, not every engine can actually use some of that ES6 syntax. In fact, when we go to Node.js, we may have to take a step down because not all of Node.js understands ES6, right? So we have to revert back sometimes to some of the older vanilla JavaScript that we learned. But then when we learn React and we go to the browser, then we're dealing with the browser, and the browser understands, the more modern browsers understands the newer features, and you can use it then, right? So with the specification of ES6 and other ES8, 9, you have to remember you have to go up and down depending on the technology you're using. You may have to go down to vanilla JavaScript, which is why we spend all the time learning it, or you might need to go up a level to the new specification, right? You just have to pick and choose what technology you're using, right? So the classic solution is the callback. So if you notice here, this is a situation where we have a callback, right? It's called function callback. It takes a function. Inside of it, there's a timeout. And the timeout is basically going to call that. It's going to invoke that function after 5 seconds. That's what it's going to do. One callback function only, but this is what nested callback hell looks like. And this is, if you can see, it's like get company from order, and then fetch the order, and then fetch the user, and then fetch the company. And you kind of get this kind of Christmas tree, this arrow thing happening, and you can imagine how many levels. So what would happen is, when I fetch it, then it returns, and then the user fetches, and it returns the order fetches, and then, so it's basically gonna go downwards and then go upwards, right? So you have a very unreadable code, and it's hard to debug. It's very, very hard to debug, and it becomes extremely messy. So the main problem is that there's only one callback per asynchronous task. So, this is async, but then, then they all start working synchronously, right? Another problem is that nested callback functions create very messy code. So yeah, it gets real messy real quick. So in ES5, we tried to solve this problem by creating those listeners, the .on. And in fact, in Node.js, everything is using this listener .on. You'll use this all the time. I mean, there are add-ins and plugins that you can use. It takes a lot more configuration. You can get Promises working with Node.js. You just have to use, you need to use packages and things like that. So you certainly can, but when you take the engine out by itself, it's basically at this ES kind of 5 level. You have to upgrade the engine in order to make it work. So there's a whole bunch of libraries, but it takes extra configuration, modification to make your engine work the way you want to work. But out of the box, we need to take a step back, use the vanilla JavaScript with it until we get good, and then we can upgrade ourselves, upgrade our server to go up a level, right? So, but anyhow, .on, this was the first deal that they tried to do, the async functions. So the async function can end before the listener is registered. So, you can register it and it can basically call right away. Yeah, so the problem with the listeners, there's no reaction when an async function ends before the listener registers. So it's hard to debug. Like some things you can fire it right away, you can't catch it. So on this example here, add the data event listener and add some callbacks. So you can set up something here, and this may look different. This may look new to you, obviously, but this will become very familiar to you in our next module. What this is basically saying is that we're setting up a listener that when some data comes in, maybe it's a piece of data, we're downloading a video, and as the data comes in, we're going to fire off a function. Every time that data piece comes in, we're going to fire off this function. It just says, hey, whatever, it's going to hello world or just output the data. So there could be a stream of data, and as the chunks are coming in, we're just going to fire it. Hey, I got it, just repeatedly, right? So it's a listener. So that was ES's 5 attempt, was listeners. But now we know we have some other options, right? So first, let me take a step back. So this is the runtime. So if you look at the runtime, there's a concept of a call stack that happens, right? And there's a heap on the left side, but really we're interested in this call stack. And what happens is certain functions get placed on the call stack in order of execution. Normally it would run synchronously, right? You have calculate numbers, add 2 numbers, subtract 2 numbers, print result. They're all going to be fired in a synchronous way on this call stack. And if you remember from stacks in our data storage, they're going to pop off the top, right? And if you're going to push one on, you push it on the top. It's not a queue, it's a stack. So last one in, first one out, right? Remember that? LIFO, last one in, first one out. So it's going to pop off the top. And the first one is a set timeout. Set timeout, though, has been deferred to another time. So they could pop that off, knowing that task is on this. So if you look at it, we're using this web API now. So this is JavaScript here, which is synchronous, but we're using this web API that has, the set timeout in it. So it allows us to act synchronously by deferring tasks to a queue. And the queue will basically, within that time, there's an event loop that's always checking, right? In Node.js, the same thing. The event loop will always be checking. It'll check the queue, the callback queue. If there's something on it, it'll pop it off and it'll put it on the stack. And when it's on the stack, then it'll actually execute, and then it'll pop it off the callback stack. So there's a lot more to this, but basically, in a sense, we're looking at JavaScript runtime on the left, which is synchronous. We're using an API, a callback queue on the right, which makes together and behind the scenes, they make JavaScript asynchronous with the concept of this event loop. Things in behind the scenes, but the language itself is a synchronous language. We have to defer on external web API to make it work the way we want it to work. So that's a bit of an overview of the JavaScript runtime. But now that leads us into promises. So I promised we would talk about promises, and here we are. All right, so the concept really is, it's a nice one actually. It's basically an object that keeps a result of an async function. So it can be waiting, pending, resolved or rejected. So it can be in a state where it's pending. So what's the state of that function? It's not finished yet. It's maybe there's a transaction that's open. I made a transaction to a request to PayPal. I haven't heard back yet. I don't know when it could come back now. It could come back 5 hours from now. I don't know. I'm in the waiting mode. I have no idea. So the function of that the status of that request or that function, hey guys, I'm waiting, right? Or it can be resolved, meaning success. I resolved. I basically I got a response back from PayPal. The transaction is okay. So I'm resolving, and I can resolve with a value, but I'm completed, right? Or rejected. Rejected means as it sounds, right? Something's happened. I don't know what happened. The transaction is faulty, data was bad, or there was an error. I'm rejecting this call, and it's basically a result. So that object can float around, and you can check the status of all those calls. So going back to my example, if I fired off, save the user account, send a request to PayPal, and then send the email out, well, I can get statuses on all of those now to see, hey, did they all succeed? Did they all fail? Or was it a mixture of both? Or are they all waiting? And based on all of that, I can now do a bunch of logic, right? So it gives, again, a lot of visibility on this stuff, a lot of control. When you fire things off synchronously, you have no idea. The only way you know that there was no problem is if the next one fires, right? So in order to get a very successful thing in synchronous code, you need all of them to fire, and you need to get to the last one and that to complete before the transaction is good. So here you can have fragmented things happening. So in a way, many of those things could have happened, but maybe the email didn't go out. Hey, no big deal. The email didn't send out. That should not stop the order from going through. Whereas in the synchronous example, that email going down prevents a sale. And now you have a sales guy or a business owner saying, hey, our sales aren't going through because of this problem, right? So anyhow, it fixes that earlier problem we had with listeners, the .on, since callback is called even though the async function completed the task earlier. Yeah, so some things can happen, and there's timing issues there with that earlier .on example. So this solves it, right? So one thing to note here is the waiting state is also referred as the pending state. So you'll get examples where you'll see waiting, result, rejected. You also see pending, result, rejected. All right, so on the left side there, you see the promise object. Again, I wanted to note that this could be pending. And you have a bunch of listeners that can be listening for this promise. And in fact, it is an async function. But it basically gives us a snapshot of what happened, which is really great for many number of things, right? History of, you can get a history on things. You can just write a bunch of logic based on the success path. You can have a path of success, a path of failure. Then what do you do if you're waiting for things, right? So again, more control over a lot of the stuff that we may want to do, which makes more modern applications, modern JavaScript. It gives for a very event-driven, asynchronous kind of application that we could potentially build with this stuff. So this is what it looks like. Um, Again, an object, you new it up. You give it a new, so you could easily just create something in a wrapper, a new promise using the promise keyword. Um, you can see there's a function that you basically gave it a function. So this is like the template, right? So you have a new promise, you have a function. You could write that in arrow syntax if you're familiar or feel comfortable with ES6. But again, this can be anything. This could be A and B, but really what it stands for is resolve and rejected, right? So we do something, probably asynchronous. Then if everything worked out fine, we basically resolve this promise. We say resolve, code worked. Otherwise, we say reject. So these are parameters that this promise already basically knows about. So we need to resolve a promise or we need to reject the promise. And if we reject it, it's good to give some information like an error to say that something happened. And then at the end of the day, inside of our function, we return that promise back to the caller, and he can do whatever he wants with this promise now, right? He can check if it resolved, he can check if it was rejected, and handle that. So new syntax to look at for sure. So to summarize, the promise object represents the eventual completion or failure of a synchronous operation and its resulting value. So basically what it says is I promise to return back to you a value of this operation, right? I'm basically making a contract with you that eventually I'm going to return. I'm going to get, it may be again 5 minutes from now, 5 hours from now, 5 days from now, but I'm going to give you the result of my operation and its value. So before I return, though, I'm in a waiting state or pending, and you can always check that. But when I have completed my action, my operation, you will see the result of it, and you can plan accordingly to it. So it's a way of thinking. We're dealing with time now, right? So it's a different concept for sure. So first, we need to declare this new promise object by saying new promise. Second, we need to pass into the constructor. So if you remember, that's like an object or a class. We need to pass into 2 parameters. The callback function for the successful completion. So we have a function here. And the callback function to handle the case where there's an error. So basically what this is setting up is that there's going to be 2 functions here, resolve and rejected, and we're basically calling them resolve and rejected, right? So you can also just resolve it, like there is actually in the promise object itself, there's built-in methods for resolving and rejected, but you can pass this in this pattern. And if you look at this here, you will see the 2 paths. This is the waiting path. You will see it fulfilled with the value, and then if this sidebar, you'll see rejected with the error. So you have 2 paths that you can code for. All right, so the great thing about these things is this then keyword. So actually, I'll get back to that in 1 second. All right, so let me just check here for a second here. I have an example here I wanted to look at. All right, so this is synchronous code. So an example of this is that I'm going to take a date.now, I'm going to say it's tick. I'm going to log, so I'm using some ES6 syntax here. If you notice, I just have this arrow function. I have 1 parameter, and I log it. So I don't need my, I don't need those parentheses because it's 1 line of code. So that's kind of like a trick. But if you can visualize this, it would be function, like you would actually have the function with the mustache braces, the braces. And then I'm using the ES6 syntax with the template literal, which are these backticks. I have the $sign with the braces, and I'm building my elapsed time in this way, right? So basically going to output the ticks. So on the main thread here, I have a code blocker. So I'm defining a function with my ES6 syntax and the arrow function. I'm going to do a while loop, which is a billion loops. And I'm going to basically keep doing it and incrementing it. And at the end of it, I'm going to return billion loops is done. Right. So basically I'm going to do that. So let's see how this looks here. So point is I'm going to log synchronous 1. So I'm going to call this logger. It's going to basically timestamp before the code blocker runs, and then I'm going to timestamp after it runs. Hopefully this doesn't take too long, but billion loops. I don't know. I'll run it and see what it does here. It's been a while. I think this, hopefully it doesn't kill this REPL here. All right. So you'll see synchronous 1 elapsed time is 1 milliseconds. Now, oh, it went faster. If you noticed, billion loops, it took 3,812 milliseconds. But if you notice, synchronous 1 was 1 millisecond, then it waited, right? And if you notice, if we run it, this synchronous 2 only was able to execute after this code blocker code was finished. So it's synchronous 1 at a time. So let's run it again. First call right away. Now I'm blocked, right? So if I increase this by another 0, imagine if this was like making a request to PayPal. PayPal is stuck processing your credit card, and you gotta wait, right? You see this on many sites. Look, I'm stuck now. I'm stuck until 10 billion loops run. I don't know how long that's gonna take, but I'm waiting for my order. I'm clicking my button. I'm clicking checkout. I don't know what to do, right? Am I gonna cancel the order now? I have no idea. I'm stuck. I don't know when that's gonna come back actually. Hopefully I didn't bust it, but it should come back. It's still thinking, right? So we'll come back to that. Oh, it just basically, did it exit out? I can't even tell. See, this is what I'm saying, is it's blocked now. I don't even know. I might as well just cancel out of this thing because it's dying on me right now, right? So it's still dying. So I might as well move on, right? So basically I basically wrecked this thing with this 10 billion loops, right? So might as well refresh it. Reload this site completely because I busted this site somehow. All right, so let's go back to this. So that's what I'm saying. Now it's kind of like busted, and I'm going to go back and reload it. Anyhow, you got the point there. So what would that look like if I used a promise now? So I'm going to do the same code, but I'm going to wrap that entire code blocker code in a promise. And it's going to get off the main thread. It's going to execute it in a micro task. So we're going to defer it. So it's going to do the same thing, but if you notice here, I have a new promise, I have a function, I have a resolve, I have a reject, but it's not used, right? I'm just basically resolving it right away with a value. So it's gonna basically resolve right away. Sorry, it's gonna defer it until it's done. So what I expect to happen is, and we'll see it, synchronous 1 should fire, code blocker should be deferred, and then synchronous 2 should fire right away. So let's actually run this and see what happens, right? Let's see, all right. So if I run this, synchronous 1, what happened? It's then you see the promise returned, and then synchronous 2 returned. So it was a little bit strange. It returned the promise, so it did go off into a micro task, but you notice it still waited a little bit. So that might not be the best way to do it. Let's look at another example here. All right, so that was a little bit of a problem, right? So what we want to do here, so what's the difference here? So here we wrapped it and returned the promise right away, but it still got hung up. It waited until this was done, which is still the same amount of time, and then in a synchronous way it resolved it. So we don't really want that because it's still waiting. So on this piece of code here, we wrap it in a promise to get it off the main thread, and then we resolve it right away. So we resolve it right away, and then there's this thing called chaining, right? So we resolve it right away, let it work, and then execute. So let's see this one if this does any better here. It's been a while, so all right, let's take a look at this one here. We'll come back to this if it's all right. Run it. It just ran right away. If you noticed, there you go. Okay, so you see that? So synchronous 1 fired right away. The promise resolved right away, really quickly, and synchronous 2, which was this call, was able to run right away. But then you notice later on, this one happened, right? So if I increase this to like maybe 2 billion, you'll see it. So with that, let's run it. Okay, let's run it. Synchronous 1 finished, promise came back, synchronous 2 finished, but now it's in behind the scenes. It's doing this 2 billion loops and it's done. So you see that delay? Because we got it off the main thread, we finished, and now that big operation's happening, and now it came back much later, right? So what we did differently was we resolved it right away. We basically just said, this is the promise and it's resolved successfully, but then deferred the execution to we deferred that execution to whenever it was finished. We got off the main thread. So now we can do all our work. And then if this billion loops or downloading 10 gigabyte video file, however long it takes, we're not going to let it block us from what we have to do. So now we can continue on and do whatever we need to do while there's like a huge, some kind of big data mining or some analytics going on or something in the background, some processes running. That background process is running on another thread. It should not affect us, right? So this is a way you can do it. So we didn't look at, so a couple things here, right? So we didn't look into this then, right? This dot then, and that's important, right? And if you see down here, it calls the code blocker, but then it handles it in a different way, right? Using a dot and a then operator. So I'll explain what that is. But those 3 examples show the difference between synchronous. We tried to use promises. It worked in a synchronous way. This truly is more asynchronous than our first example because this code blocker did not affect us. It basically, we deferred it. We got it out of the way so that we unblocked ourselves using asynchronous operations, right? It's pretty powerful, really, if you really think about it. And I'm not even getting into like some of the newer syntax, but it's pretty powerful. All right, so promises, right? So you kind of get the idea of the promise. There is this method on the promise called then. So what it means is that it says the then method returns a promise. So it takes 2 callback operations for the success and failure. So basically it's saying, do the promise and then do this. That's kind of what you can read it. So whatever that promise is, if it's a code blocker that does 1 billion operations, well, go do all that. And then when you're done, I'm going to handle it this way, right? That's kind of what it does. So this is a very quick example where we have a promise that resolves success right away. So then that handles the success here, right? The function will take that value, and the value is this success string, to say that slowly. And it's just going to console log it, right? If this had a timer here for like 5 minutes, or if it had a while loop or something, it'll wait until this is resolved, and only then will it handle it. That's kind of what it does. So it basically is a way of waiting for the return value of the promise. It will not fire while the promise is in a waiting or pending state. It needs to resolve or it needs to reject in order to handle it. Right. With this thing, though, we can do something really cool. We can do chaining. So we can chain all of these things, right? So we can use multiple then methods on a promise. So we can say, in an example, go and fetch a bunch of stuff. So we haven't looked at the fetch API, but basically this would say, go get a bunch of data from somewhere. And when you return, go get more stuff, right? So this would be the first operation, right? When you return, then go get more. After this whole thing returns, then I'm going to say succeeded. Otherwise, I'm going to do something like we learned today with this try catch. I'm going to catch the error, right? So So if all of this has an error, I'm going to catch it and say it failed. Otherwise, this will execute, and then I'll handle it when it returns. When all of that returns, then I'll say it succeeded. So you can chain a bunch of stuff based off a promise. So it's a lot to take in, but if you wanted to say, going back to my original example, if you wanted to fire off, save the data, save the user, fire transaction off to Moneris, but when the Moneris request comes back, maybe you want to do something else after that, but it's in that chain of events, right? Maybe when Moneris comes back with the success, maybe you need to, I don't know, issue a token or something like that. Maybe you need to issue a token for some kind of information on what happened to that user, right? Or maybe you need that token to then log them in automatically to the member site, right? And then redirect with that token. The whole bunch of things you can do, right, around this. So it gets really, it allows for very complex stuff and also a lot of control over a lot of things, right? Especially if here's another example. If you were, you load up a page and you want the page to load, you want everything to, suppose you have a bunch of drop downs and you need to populate a bunch of drop downs. Maybe you need to go and fetch all of the gaming consoles, right? All the different types. And you need to go and pull a product list for a data grid. And you need to, I don't know, get some other data. All those requests can fire at the same time. And then only then when they're all done, then you show the page, or you redirect the user, or you hide the loading thing. So you can chain all of that stuff here, and only when they're all done, hide the spinner. Otherwise, catch the error and throw like a nice toaster message. If you don't know what toaster message is, it's like a nice little alert. Something failed, right? Transaction failed. Please contact your administrator. So a lot there. So the then operation returns a promise, which allows for chaining. The callback function can then return a resolve or rejected. So you're going to see the same thing all the time: resolve, rejected, then catch. Like, these things will be interchangeable. You'll use them a lot. Reject, like we said, it is what it means, right? The promise.reject methods returns a promise object that is rejected with a given reason. So it returns an object. If you see here, you have a resolve function. If you wanted to use it, it just says resolved. It has a reject function. It just says the result in this promise. We reject it right away. We give it an error, the error method, and then when this returns, which it does right away because we reject it right away, right? We say .promise, reject it right away with this error. Then the resolve thing will not be handled. The rejected one will be, right? So this function here will be handled. And as a parameter, it will take this error right there. So yes, so promise is started. We reject it right away at this value. Only when it returns do we handle this rejected state, because now it failed. And it failed with those details. So the result is that new error failed. So again, you have to code this yourself and experiment with it. You have to see it in action to understand it. Resolve is a happy path. Resolve is what we want. So the resolve method returns a promise object that is resolved with a given value, right? The rejected had the error object. This one has the given value. So if the value is a promise, so yeah, you can have a situation where you return a promise you can chain all those things, right? If the value is a promise, that promise is returned, you return the promise. If the value is a thenable, which has a then method, so we can, basically we're saying is, without reading this too much, is you can chain all those thens, or you can just return the promise object. However you want to handle the flow, you can handle that flow. What's the warning here? Do not call promise resolve on a thenable right away because it resolves itself. Yeah, so if if you're resolving things in the way right there, you're going to basically immediately like execute it right away. Sometimes you might want to do that. Sometimes you don't want to do that. So in this situation, it will cause infinite recursion here. So it tries to do some weird things, right? So you got to play with this because you can get caught in the asynchronous world where it tries to do infinite recursion on you. You have to play with things in a way, you know, in our example, we resolved something right away. If we go back to add some speed to it, let's see, in our example right here, we did this, but we returned it right away, right? We returned this whole thing right away and deferred it, right? Whereas this example here, we're just basically setting it as a parameter, and it's basically, you can get in some very weird states is what it's trying to say, right? And in the asynchronous realm, you're going to get into some very weirdness with async stuff. It gets complicated, right? To solve that complication, we have a lot of this try catches. So we can actually have the catch functionality here and the finally that we learned, but they're the dot to that object, right? So if you have a promise, you have the dot then, as well as you also have the dot catch, as well as you have the dot finally, and they work in the same way as our try catch that we learned previously, right? You have that piece of code. If it fails, in this example, there is somebody threw an exception, therefore it will be captured in that catch, and we'll console log it. At the same time, after all that executed is done, we have a finally flag, finally clause. If you see it there, it's a function that sets a flag is loading as false. So in that situation there, maybe that loading flag hides a spinner, right? Based on that status of that flag. So same type of things that we learned before try catch. So on the promise object, there is a catch and there's a finally. The catch method returns a promise and deals with that rejected case only, right? There's an error. That means that there has been a rejected promise, and it deals with that clause. The finally method returns a promise. When the promise is settled, either fulfilled or rejected, callbacks execute. So again, it's basically the last thing that gets fired right away. Got to play with it. It's a lot to take in with promises. And there's another one which is very cool. So this one's a very good one. So basically what this is saying is there could be 100 promises, 100 of them, right? And you can put them all inside an array. You wait till all of them are done. So basically all of them are done. So maybe you have, like I said, in my situation, you know, if it's a checkout and you have all those steps, you could load them all up in this array. Only when they are all done do you redirect a user to the order summary page, because at that point in time, the entire order has been completed. You're good. Everything has been, whether it's not, it's, let's see here. Returns a single promise that resolves when all the promises past and iterable have been resolved, or when the iterable contains no promises. So when they're all done. So here in this example here, the first promise resolves right away with 3. The second promise is a number, which is 42. The third promise is a timeout. So basically that's going to resolve in 1 second or 100 milliseconds. So basically what it's saying is promise 1 gets resolved right away. Promise 2 gets resolved right away. Promise 3 may wait a little while, but we're not going to hit this then, even though the first 2 are done. We have to wait for this slowpoke to finish up. We're not going to do anything until all of them have completed. If this guy takes 5 minutes or 5 days, we're going to wait until he's done, even though these guys are already finished. When all of them are finished, then I'm going to output, hey, here's the values, or I'm done. Everything is done. So it's a way of controlling all that asynchronous stuff. You can do it using this .all method, right? So again, this is intermediate JavaScript. So this is already harder than what we learned with while loops. This is a step up, right? When we get to Node.js, we may not use promises right away, but it's getting us ready for React. especially when we need to deal with data from APIs. We need a way of firing all of that and handling when the data comes back, and you'll use promises for that. I didn't list all the methods because you need to really look at the built-in objects. And yeah, like I said, this is intermediate JavaScript, so it's going to take a little bit for it to sink in. But with that being said, let's watch a video. Yeah, why not? I'll play this for you guys. Let me know if you can't hear this, by the way.
The one safety deemed such destruction.
I'm not going to skip this because this is actually a really good show, so I watched the first episode.
You expect me to search the galaxy and deliver this creature to a race of enemy sorcerers?
This is the way.
The Mandalorian, new season, now streaming.
It's a good show.
Okay then, so we've seen now how to request data from different sources, one after another, sequentially. So we get the first to-dos, then we get the second, then we get the third. And we did that by nesting the requests inside callback functions, inside callback functions, inside callback functions, etc. And if this carried on in this pattern for much longer, this would get quite messy, unmaintainable, and it's just not a good idea. So it would be nice if there was an alternative way to do this in JavaScript, and there is, using something called promises. So what I'm going to do is explain the whole concept of promises first using a simple example. Then we're going to take what we learn and apply it to this example right here where we make this network request. So first of all, let me get rid of all this junk. We don't need that anymore. And then I'm going to say promise example first of all. So I'm going to make a new constant and I'm going to call this get something, and this is going to be equal to a function, and inside that function ultimately would be some kind of network request. Much like up here we have get to dos, and inside is some kind of network request. So we're going to do something in here like get data. But when we use promises, the first thing we do is return a new promise, like so. Now, a promise is basically something which is going to take some time to do. So a promise is ultimately going to lead to one of two outcomes. Either a promise is going to be resolved, meaning we get the data we want and it's resolved, or it's going to be rejected, meaning we get an error at some point and we reject the promise. So there's the two outcomes of a promise. Now, this promise takes as a parameter a function. So let me pass through an arrow function right here. And inside this function, this is where we typically do the network request. We maybe fetch some data. So let's just say fetch something. Now, we're not going to do that because I'm just doing a simple example. So I'm not going to do a whole network request again down here. But imagine we did. Now, I just said inside a promise we do one of two things. We either resolve it when we get the data, when it's a success, or we reject it when we get some kind of error. Now, that's very much like up here. We either get some kind of success in this case or some kind of error down here. So in a promise, we automatically get access to two parameters inside this function, and that is a resolve parameter and a reject parameter. Now, these two are functions and they are built into the Promise API. I've not just made these up. They're built into the Promise API in JavaScript, and we automatically receive these as parameters in this function. So in here, we typically fetch some data, make a network request, and then if we get some kind of data back and it's a success, we'd call the resolve function and we'd pass the data through in here. Now, we're not making a request and we don't have any data, so I'm just going to do this by passing a string and saying some data. So really that would be our data, but we're resolving with some dummy data, which is just a string. Now, if there's an error instead, we'd call reject and we'd pass the error through. But again, we don't have an error because we've not made this request, so I'm going to just say some error instead. And that's all there is to it. Now, what I'm going to do is test these out one at a time, because typically what we do is some kind of if check to see if there is a success, and then if that's true, then we'd resolve. If not, then we'd reject. So I'm going to do one of these at a time. So let me comment out the first one, and imagine now when we call get something, we return this new promise, and this is a success. We fetch the data, it's fine, and ultimately we resolve with some data. So now if I come down here and call get something like this, then this right here, this will return a new promise ultimately, and inside that promise it's either going to resolve or reject. So we returned a promise right here, and a promise is basically saying, look, I am going to do something at some point. I'm either going to resolve or reject at some point. Now, when we get a promise back from a function like this, we can tack on a dot then method. And a promise is basically saying, okay, well, if you pass a function in here, then I will fire that function when we resolve the promise. So if I pass a function through here now, like this, I can take the data that is passed to me when we resolve. So when we resolve something in a promise, it fires the callback function inside the then method. And that callback function takes the data that we pass through to the resolve function. So down here, I could say console.log the data that we get back, which is just going to be this thing right here, some data. So let me save this now, and we should see this in the console, and we do some data. Okay, so that's if we resolve a promise. Now, if we reject a promise, we also get a second callback function as a second argument inside this then method. So I could do now another callback function, and this callback function would only fire if we reject. So the first callback function inside the then method fires if we resolve, the second one fires if we reject. And again, we get access to the error in here, which is going to be this in this case. So I could say console.log the error.
Do you want to learn all the skills and techniques you need to create incredible?
So now if I save this, because we're rejecting the promise, when we reject, it's going to look at this then method and fire the second callback function inside it. So let me save it, and now we get some error. So this is promises in action. We either resolve something or reject something and then fire one of two functions depending on that. Now sometimes when we're adding two functions as arguments into the then method, it can get a little bit confusing and look a bit messy. So I'm going to show you a slightly different way we can write this. I'm going to say get something again. Again, we tack on the dot then method, and again I'm going to pass through a function as the first argument, or the only argument in this case, and this will fire when we have a resolve. So again, I'm going to take in the data, and because there's only one parameter, we can delete those parentheses. We could have done that up here as well. And then inside, I'm going to console.log the data. Now then, instead of having a second function right here for the reject case, instead what we can do is tack on another method called catch. And what this does is catch an error. So this works the same way. I'm going to place error here and do another function inside the catch method, and I'm going to say console.log and then pass through the error. So instead now what happens, when we get a resolve, the then method fires and fires the callback function for that resolve right there. And now if we get a reject with an error, instead it comes to the catch method to catch that error, and then it fires this function right here. And this sometimes looks a bit neater than this, especially when it comes to chaining promises together, which we'll see in the next video. But anyway, this is going to work the same way. If I save, currently we get some error, and if I comment that out and this time resolve, then I'm going to get this right here. We get the data, some data. So that is the basics of promises, but it might seem pointless before we actually do something proper with it, because this is just a dummy example. So instead what I'm going to do is come up here and return a promise inside get to do's. So I'm going to come up here and I'm going to say return new promise, and inside this promise, remember, that is where we fire a function which is going to go out and do this network request. And now that is all of this stuff right here. So let me cut that and come up here, and I'm going to paste all of that back in. Let me just scoot this up. So now we're returning a promise, and this promise is now doing all of this stuff. So remember, inside this function, we take the resolve function and also the reject function. And we have to call either one of these dependent on the state of our request. So instead of now calling a callback, which we don't need to pass in anymore, we'll take that off. Instead, we're going to either resolve or reject. So I'm going to resolve here because that's a success case, and I'm going to pass through the data right here. Now in this case, I'm going to reject, and I'm going to pass through some kind of error, which is error getting resource. Now then, if I call this function get to dos down here, let me do that. I'll say get to dos, and what I'm going to do is just pass in first of all the resource, which is going to be Luigi. So I'll say to dos folder / Luigi.json. Now we don't need a second parameter anymore because we don't need a callback now. Instead, what we do is we tack on a .then method because this is now returning a promise. And when something returns a promise, we can tack on the .then method, which takes in a function. That function is going to fire with the data we get back when there is a resolve case. Now I'm going to delete these parentheses because there's only one parameter right there. And inside here, all I'm going to do is console.log, and I'm going to say promise resolved, and then I'm going to output also the data that I get back. Now we could add a second function here, which is going to run if we reject the promise, but instead I like to use .then, and then inside here we pass a function, and that function is going to take the error that we receive back, and then all we'll do is console.log promise rejected, and then the error. Okay, so let me give this a whirl, and in fact let's delete those parentheses again, give this a whirl, and that is all going to work. So if I save this, now we can see the promise is resolved right here, and we still get this promise rejected. So let's see what's going on, and it's because silly we've used then again. This should be catch, obviously, so we're catching the error here. We have the then method, then the catch. So now if we save it, we can see only promise resolved, so we get that data, it's all successful. If now I change this to something like Luigi's, which doesn't exist, save that, now we get promise rejected, error getting the resource. So this is another way, other than using callbacks, to work with asynchronous code. And this is really going to come in handy when we try to sequentially get data one after another, because we're going to be able to chain promises together. So we've already seen how we can nest callbacks to do this, and this resulted in messy, unmaintainable code. So we're going to look at how promises can do the same thing in a much better way in the next lecture.
Show me the one.
All right. All right. Yes, I will. Yes, I will. Okay, sure. Let me copy this right here. Based on that, I will share this. It's good, it's good to look at this from different angles, because there's a lot of different ways of explaining it, and I only have a few more slides, and I'll let you guys get to some of this. But yeah, there's many ways to explain it, different viewpoints of it. Can we have timeout for promises? Yes, you can wrap a timeout within a promise. Yes. As I might have done already in here somewhere. Did I do that already? Somewhere in there you can wrap it. Sorry. Yes, you can. Well, yes, you can certainly do it. The while loop is exactly the same as a timeout, right? Right. So I wanted to mention callback versus promises. Did we get to this? Sorry. Callback function only. So we remember this, right? This view here. So we have that timeout here. Yeah, that's the example right there. Sorry. So we have this update method now, and we have a function, and we have a promise in here. Promise resolves after. So we are setting a timeout within a function. So this promise will resolve after 5 seconds. And then we're returning this promise. So when this person calls this, it's going to wait 5 seconds, 5 hours, 5 days. Only then, when it's done, will it then output the slow data, or otherwise handle the error, right? So if you just look at this cleaner code right here, right? It's a lot cleaner. It's a lot more readable than the catch compared to this. So this is basically, we're looking at the callback and we're going to see what this callback hell looks like. So this is what it looks like using Street Fighter. Yeah, it's Ryu, right? Not Ken? Yeah, it's Ryu. He's doing his, what was that called again? Hayuken, right? Just to demonstrate here, this is what you can get into, right? Callback, 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 callback. You kind of get this Christmas tree effect going on. Really difficult to understand, really difficult to debug. You can kind of see here, go and get the loader, do something with it, then go and get all of these dependencies, and then as they come back, they call back, they call back. So you got to make sure you get all these dependencies until you get to the top, and this is hell, right? So this is what we don't want. When you have nested callbacks versus promises, right? So the main advantage of the nested promise, you can flatten it to avoid that callback hell. We don't have this situation going on. We have this, so this is the example from earlier, get company with all these callbacks going on, as you can see. Here we have one function that has a promise that you can see they're chaining, right? So fetch the order, then fetch the user, then fetch the company, return all of that, and then handle the result of all of that nicely in a very nice way. You can see there, get company from order. When that is all done, then do something with that, right? So clarity of code, you can already see. I prefer the left one over the right. All right, so that, guys, is a lot to take in, no doubt. But you know, I think the average in full stack 1